Glad to see you here. So today we're going to talk about Spark Bench. It's a really interesting platform for doing a lot of different things, not just benchmarking. So who am I to be talking about, who am I to turn my remote on? Who am I to be talking about Spark Bench? I'm an artist and a former documentary film editor, and now I'm a Scala developer on the Watson Data platform. I have strong opinions weakly held about spaces and tabs, and more importantly, I'm the lead developer on this little project called Spark Bench. My team and I are based out of Atlanta, which is the best city in the world, although Dublin is very, very nice. We have great music and culture and art and the river with whitewater kayaking right in the city. But unfortunately, I'm not here to talk about Atlanta, even though I really, really want to, and I could. Instead, we're going to talk about Spark Bench. So I'm going to walk you through the history of Spark Bench and the motivation for a big recent rewrite. And we'll go through a bunch of examples so you can get a feel for how it might fit your use case and how you might be able to take advantage of the new features. So let's start with a history lesson. I want to take us all the way back in time to the year of our Lord 2015. In 2015, in between sieging castles and jousting, we were very excited about Kendrick Lamar's new album. And we were arguing over what color this dress is, and we were really excited about Spark 1.4.0. Isn't that a throwback? Spark benchmarking back in 2015 was kind of a mess. There were some open source projects, there were some closed source projects, but it was mixed in with a lot of trying to compare it to other frameworks like MapReduce, and it was just a mess. So in these dark times, these dark ages, stepped the White Knights of IBM Research with this project called Spark Bench. And they sought to make a framework that was a single authoritative source of benchmarking specifically for Spark. So not trying to compare against other stuff, but just for Spark. And the citizens of 2015 rejoiced with a great feast because it was great to see these kinds of performance numbers about Spark specifically. But let's fast forward in time to the year of our Lord 2017, a year that you might be familiar with. A lot has changed in that time, and definitely the most consequential things have been that Beyoncé released a new album, and we can now definitely tell what is a hot dog and what is not using the power of AI. And we now have Spark 2.2.0. Another thing that's changed at IBM is that we've been working on the Watson Data platform. So this is a series of services meant to assist the developer with their big data applications, and many of these leverage Spark. So what we saw as my team in Atlanta started to look at this, doing Spark improvements, is that the Watson Data platform had a lot of benchmarking needs that weren't covered by Spark Bench. So the original Spark Bench met this user story. As a researcher, I want to run a set of standard benchmarks with generated data against one instance of Spark one time. So I looked at that and I said, okay, that's a great start, but let's keep going. So I want to cast a vision for us. A vision of a Spark benchmarking system that is more than benchmarking, where we can test and compare and exercise in a flexible framework that lets us do so much more than just traditional benchmarking. So let's take a look at some of the use cases for that. How about, as a Spark developer, I want to run regression tests with my PR so I can prove that my changes help things out. Okay? How about, as a Spark developer, I want to see nightly regression tests to see what's changing, what's getting better, what's getting worse. How about, as a Parquet developer, or somebody else broadly in kind of the third-party ecosystem, I want to run benchmarks against versions of Spark built with different versions of my stuff so that I can see what's working and what's not. How about, as a Spark developer, I want to simulate multiple notebook users hitting a cluster at the same time so that I can test my changes to dynamic allocation. And if you were around yesterday, you might have seen the talk by my colleagues Craig and Brad, also from the Watson Data platform. This is exactly their use case. How about beyond the Spark developers? As an enterprise user, I want to make sure my daily batch jobs are running as fast as possible, so I want to run it through a benchmarking framework and tune some parameters. How about, as a DevOps professional, I want to see performance changing as our cluster scales? How about, as a data scientist, I want to run a lot of machine learning algorithms on this data set in an organized way, in a repeatable way, where I don't have to rewrite the code every single time to do discovery. And if none of those fit your use cases, then maybe this last one will. As anybody who has ever had to make a graph about Spark, I want to spend less time doing experiments and more time making beautiful graphs with my easy-to-produce numbers. So that's the vision for the new Spark Bench rewrite. Let's see what's implemented and how it works. I want to start with just some structural details. The old version of Spark Bench was a series of individually compiled Spark jobs, mostly in Java, mostly compiled with Maven, and it was tied together with a bunch of Bash. So if you wanted to do configuration, you could dig around in the Bash, you could do different things, and if you wanted to benchmark something else, you could write a new whole Spark Bench project that was individually compiled and write your tie-ins in Bash. So that's all changed. The new version is a Scala framework, which is built using all the modern niceties of continuous integration, continuous deployment, all that stuff. All the configuration is centralized in one config file, and I'm gonna hammer on this really hard until you're sick of it. All the configuration is in one place. We have 3 different levels of parallelism. The old Spark Bench had no concept of parallelism. And we allow you to bring your own custom workloads in your own little package jar without having to change the source code. But you didn't come here to see tables about this stuff. You came here to see plain text configuration files. So this is a very minimal plain text configuration file for Spark Bench. You can see off the bat that it's a nested structure. So I want to start in the middle of that or at the bottom of the tree with workloads, and we're going to build our way up to see what kinds of features are in Spark Bench and how you can take advantage of them. So a workload is kind of the atomic unit of Spark Bench. It's anything you can do with a data frame or without a data frame. You can optionally read from disk, optionally write to disk, do whatever algorithm you want. All the stages of the workload are timed individually, and you can compose them together. Right now, available in Spark Bench, we have some machine learning stuff, like k-means and logistic regression. We have SQL queries, so you can throw a SQL string at it. And we have some oddball stuff. We have SparkPy, which is a computationally heavy workload that estimates the value of pi, which isn't useful in real life, but it's very useful for hammering hard on the compute side of Spark without touching the I/O. We also have Sleep, which I'll talk about in a little bit, Cache Test, which is a weird workload to exercise a really specific subsystem. We also have data generators, and these are treated exactly like workloads. So you can even get benchmarking numbers on your data generation if you care. And if you're looking at this list and you don't see the thing that you are interested in, there's 3 answers to that. This is an active development, so there's more coming. I would love your contributions. And you can bring your own workload, which I mentioned before, but let's dig in. So the way this might look is you implement our abstract class, compiled locally, and package your own jar. And this might be our gigantic daily ingest job. You might package that into a Spark Bench format, and then you can use Spark Bench to tune your parameters. The bottom example is something you can see straight in our documentation right now of how to do this. It's a custom data generator that'll build you a data set of all the same string, which I'm sure is really useful. But it's an easy to follow example. So that's enough plain text. Let's look at this visually. This is a workload. It's really amazing, isn't it? And this guy could be anything. He could be SQL, he could be SparkPy. Today he is SparkPy. So I write this little HOCON configuration block. HOCON is a superset of JSON, basically, and configure it that way. And I know how to configure it because I looked at our great big beautiful documentation site which has all of the parameters listed out so that you know what to plug in. So my little SparkPy workload has a friend, and he's a data generation workload. And he is configured the exact same way. So data generators have some typical parameters for them. Again, you can see those on our documentation site. So I can configure him in pretty much the exact same way. And I can do this to make big data sets, little data sets, and this may not seem like a big deal, but this was not possible in the first version of SparkBench. It was kind of preset. So we can compose these workloads together in different ways. We can have them run serially, one after the other after the other. We can have them all launch in parallel, so they launch at the same time and run as they run. And the setting in which we control that is the workload suite. And that's exactly what it sounds like. It's a logical group of workloads. And in this one step up configuration section, you can control how your workloads run, whether they're serial or parallel. You can control where you output your benchmark results. You can control how many times you want to run this suite. And workload suites are composable with each other. So going back to our dots and circles here, this is one workload suite with 3 workloads running serially. So I've set parallel equals false, and that means our workloads are going to run serially. If I flip that Boolean, it's the same thing, but I'm launching my workloads in parallel. So composing these together, I have 3 workload suites running serially. The last guy is launching his workloads in parallel once we get to him. So what I'm trying to emphasize here is that SparkBench is giving you a lot of control about your levels of parallelism, and you can control them independently. So if I flip the suite's parallel Boolean here, I get this, which is the same thing, but I'm launching my suites in parallel. And if you're looking at this and you're saying, this is really great, but it's just not enough parallelism for me, don't worry, because we have another level of parallelism. Under the hood, SparkBench is basically taking your configuration file and launching Spark submits from that. So this next level, you can control anything that you would control in a normal Spark submit script. Now, this is useful for controlling your Spark parameters, your tuning parameters, all that kind of thing, but it's also useful for simulating different use cases. So sometimes you have a lot of stuff going on inside of one Spark context, but sometimes you've got multiple Spark contexts launched on your cluster. So SparkBench gives you both. You can launch multiple Spark contexts through the Spark submit config. So we can control anything you would control with Spark submit script and run against different clusters, different builds of Spark, different versions of Spark even, to an extent. So that looks a little like this. Now we have a box to add to our dots and circles. This is one Spark submit with 1 workload suite and 3 workloads running serially. This is 2 of them composed together where I'm launching the Spark submits in parallel. Spark submits serial. And again, the levels of parallelism are independent. So in that second Spark submit, my workload suite is going to launch its workloads in parallel. So these are kind of academic examples, but this is a more real-world example. This is what traditional benchmarking would look like in this visual metaphor. So I have 1 Spark submit with 2 workload suites. In the top, I'm launching a bunch of data generation workloads all in parallel because I don't care how long these take, and I don't care about getting clean benchmark numbers on them. I just want to generate my data and be done with it. In the second workload suite, and these are composed serially, so I run my data generators, and then I run my workloads. And these I want to run serially so that I get a clean read on my numbers, and I want to repeat that whole suite and get some statistically valid results on that. So this is what that would look like more or less in the configuration file. So everything's surrounded in this SparkBench object, and then we go down to the Spark submit section where we control what our master is and our parameters. Then we have suites parallel equals false, so I'm going to run these serially. The first one generates our data, and it runs the workloads in parallel. The second runs serially, and it's going to repeat a bunch of times so that we can get good numbers on the algorithms we care to benchmark. So once you do this, you run it through SparkBench, and it returns you a bunch of numbers. And from that, you can build really, really beautiful graphs because you didn't spend any time running your experiments. So you can build 7-layer Venn diagrams if you really want to, because you've got to save all of this time using SparkBench instead of writing this stuff yourself. So I want to take you through a bunch more examples. This is going to be our detailed example, and this one's very close to my heart. In the spring, I did a talk about Parquet versus CSV and why Parquet is so much faster. It is. And for those benchmarks, I had to do that all myself. So I wrote a bunch of one-off scripts, and I overwrote my data, and I had to do it again, and it was a giant mess. But if I had had SparkBench at the time, this is how I would have done it. This is going to be a really detailed walk of a real-life configuration file, so hang on, we're going to look at some plain text. So at the top, SparkBench object, then I set my Spark home. I set my master to yarn and configure that. I turn off some configuration objects or options that my colleagues had turned on by default on this particular cluster. And then I say, I want to run my workload suites serially. So my first workload suite, I generate some data. And I want these workloads here to run serially. So in the first one, I use the k-means data generator to generate a big old data set, slap it in not S3, HDFS in this example. It could be S3 though. In the second workload, I'm going to use the SQL query to pick up that exact data set and transform it into Parquet. So instead of generating two similar but different sets, I make sure I have the exact same data in two different formats. In the next workload suite, this is where I actually run the benchmarks that I care about. So I'm actually running 4 workloads here, configured with one block. So if you'll see in input, I have 2 different inputs, and then in query, I have 2 different queries. And this is a cool thing in SparkBench. I think it's cool. It'll pick up these 2 lists and cross-join them and produce all the variations on that workload. So this is 2 cross 2 is 4 workloads from this one block. So from this, I run my numbers, and I get this, which is a lot of results. So this is your benchmark numbers, this is your Spark parameters. In the future, we want to put your hardware parameters and anything we can pick up about your operating system, anything that would affect what these numbers are for the broader community. And from that, you generate beautiful graphs. And this is a beautiful graph. And by the way, Parquet is very, very fast. That's a different talk. We're not going to go into that, but it is. And this, I just tossed it into Zeppelin with those numbers, and this is what I got. So more examples. I call this one the cluster hammer. We're going to go brief on these last few examples. The cluster hammer, we have a bunch of workloads and a bunch of workload suites. They're all running parallel in a Spark Submit. But that Spark Submit's lonely, and he needs some friends, and they need some more friends. So in this way, I can stress test my cluster. I can just hammer on it as hard as I can. I might be doing this with something like SparkPy, so I can hammer on the CPU side of things. Or I might be doing this with some dumb, like, reading data, write it out somewhere, so it's basically all I/O with very little compute. You can do this in a variety of different ways to just hammer on your cluster. Another example, multi-user notebooks. So this is more or less the example that Craig and Brad were working from for their talk yesterday. This slide's a little dense. Let me walk you through it. We have 2 Spark submits composed serially. In the top, we have one workload suite with 2 data generation workloads. Those are running in parallel, because why not? One of them is generating a real small data set. The other is generating a gigantic data set. So that's our data generation. In the next Spark submit, we have 2 workload suites, and these are our users. So our users are going to be doing jobs with these 2 different data sets. One's going to be using the really small data set. The other's going to be working with the gigantic data set. And what we're trying to see here is Will the little guy get any resources, or is he going to get starved out by the big guy? A thing that lets us do this really accurately to real life is that interspersed between these workloads, we have the sleep workload. So you might have seen that on the list and wondered what that was about. There's some papers about how you can model user interaction in a terminal environment on certain distributions. So we've got all those distributions in the sleep workload, so you can intersperse, you can also just specify time, but you can intersperse something like that distribution in between your workloads so you can simulate one guy launching a gigantic job, going to get coffee, forgetting about it for a while, or maybe just reading Hacker News or whatever. And this gets you a really accurate simulation of what these notebook users are actually doing. There's a lot of easy extensions you could do to this. You could add more users, you could put this against the cluster hammer, see like even more resource contention. You can toggle settings for dynamic allocation, you can do all kinds of stuff, and that's really easy to build off of once you have that initial configuration file. So last example, I just want to emphasize here that you can tune your Spark parameters. So here I'm using a similar thing where I've got two different Spark homes. So in this case, I'm benchmarking against the official version of Spark and my version of Spark with all my new changes so that I can do those authoritative tests about which one is better. I could also do something like vary this over the amount of executor memory. So here I've got 2 options in Spark home, 4 options in executor memory, so I get 2 cross 4 is 8 Spark submits out of this. So yes, it is very easy to absolutely blow up the number of Spark submits or other options you have using this, but sometimes you need to do that, and Spark Bench makes it really, really easy to get all those variations. And you run these variations, and you do all these things, and you get your numbers, and you make beautiful graphs, and your correlations just fall out from the sky. You know, you can just relax and build some graphs, and it's gonna be great, and you can do some word art to go along with it. A few final thoughts. This is really easy to install, at least in my opinion. Grab the latest release from our GitHub. This is being released very, very often, usually at least once a week. So grab the latest version, unpack the tar, set your Spark home, and run the examples, assuming you have a working version of Spark. So that's all it takes to install. Where is this going? It's going a lot of places if I have anything to say about it. We're looking at adding a bunch more data generation workloads and other algorithmic workloads, especially porting things that were available in the legacy version of Spark Bench. I want to add TPC-DS because that's becoming kind of a standard benchmark for stuff. And really, the sky's the limit. So this is where I ask for your help. Contributions are very welcome and even encouraged. And if you are me several years ago and you're sitting in the audience wondering how to get involved in an open source project that's really cool and don't know how to take a first step, please come talk to me. We have some really low-hanging fruit where you could get involved quite easily and really make an impact. I want to give a quick shout out to my team in Atlanta, Craig and Brad, who you may have heard yesterday, Brad, my faithful beta tester, and also our colleague Matthew, who has been very instrumental in implementing a bunch of these features. And just to summarize, don't mind if I read this straight from the slide. Spark Bench is a flexible, configurable framework for testing, benchmarking, simulating, comparing, and more. There's a GitHub repo, and that's all. Thank you for coming.
All right, go ahead and start with the questions. Thanks.
I love the single config and the parameterizations you've done. One thing I didn't see, I'm interested when running Spark jobs, how much time was spent shuffling, what kind of network throughputs I was getting, time in memory, CPU. I didn't see those statistics captured by this tool.
Sure. Yeah, and that's fair. So Spark Bench is kind of at the level of the application. So if you wanted to dig in a little further, you could tie this in with a profiler. There's a lot of profilers out there available. You can look at Spark UI, but that is true. It doesn't give you detailed CPU, but it does give you any kind of benchmarking numbers you could get from an application level.
Hey, so actually I have a couple of questions.
Uh-huh.
So one is, what's the output format, and is it possible to have those sent out to like a metrics collection repository? So that way, like if you wanted to do nightly builds, you could just then look at a graph and be able to see all of those metrics.
Sure, yeah, the output format is whatever you want it to be. So it could be CSV or Parquet, or basically it's wrapped around the Spark data frame writer. So anything the Spark data frame writer can do, this can do. So it can go to S3, it can go to HDFS, it can go to all those places in whatever format you want.
The actual benchmark results get written out as like Parquet or CSV?
Yes.
Okay.
And optionally, if you want to write the actual results of your benchmarking, so if you run, for example, a SQL query benchmark and you want to actually output the results of that SQL query and not just the benchmark numbers, you can do that too. And same thing, that can be any format, anywhere.
Okay. And then the other question is, could you possibly tie this at all to the Spark metric system? So like, you know, some of those like shuffling metrics or CPU, JVM heap metrics that automatically do get collected. Is it possible to funnel those into the benchmark results?
That is a great question. That's not something I've looked into, but that would be an awesome addition if it's possible. So if you want to talk about that more offline, I'd love to.
Okay, cool, thanks. All right, thanks again. Round of applause for Emily again. Thank you.